Hello, PreCalc. We're going to talk about Eqns section 8.4, equations of hyperbolas continued. And in this section, we're going to have two objectives. The first is to determine the center, foci, directrices, and asymptotes of a hyperbola from an equation on a graph, or a graph. And the second is to write the equation of a hyperbola from a given graph or information about its center, foci, directrices, or vertices. So let's look at our first problem here. So what's going to be different about these ones from the last set of problems is that the center is no longer at the origin. So we're going to move the center, which makes our distances more important. Okay? So let's look at this equation right here. Let's get all of our information. Remember, our center is at HK, and remember, it's always minus H and minus K. So essentially what you got to do is look at this and this and take the opposite of what you see. Okay, so the thing with the X is the H, and opposite of -1 is +1. The thing with the Y is +2, opposite of +2 is -2. So there's my center, 1, -2. My A is always underneath the first one, and remember, those are squared numbers. So A squared is 4, making A 2. My B squared is always under the second part, and that is 16, making my B the square root of 16, or 4. So now I have a whole bunch of information. Should be enough information to do what I want to do. The key to this is drawing it. I know Eqns just gives you a formula that you can plug in and you don't have to bother, but a lot of times you won't remember that formula, right? However, if you remember the general form and what it looks like, and you know how to graph these things, you'll be able to figure it out, okay? So let's take a look at a rough sketch of the graph. First of all, because the X is first, I know it opens in the X direction, like that, okay? So that's the first thing that I know. Second, I know these distances. So my A distance is 2. That's going to happen in the X direction. Oh, but not from the origin. Hang on. So let's mark our center first. 1, -2. So from here, my vertex is in the X direction, a distance of 2 in both directions. So 1, 2. There's a vertex. And then 1, 2. There's a vertex. Okay. And then my B distance helps me to create my box so that I can see my asymptotes, right? So a distance of 4 in the other direction, in this case in the Y direction, that is the direction of the second part. So that's a distance of 4, so 1, 2, 3, 4 in that direction. So there's a mark for B there. 1, 2, 3, 4 in that direction. So there's a mark for B there. Let me put my rectangle in I'll do that in green here. And I'll mark my asymptotes in green as well. Goes through the corners and through the center. So, in order to write the equations of lines, I either need, you might remember, slope and a point, and I could just put it in point-slope form there. Although I think Edgenuity wants it in slope-intercept form. I'll show you how to do both. Or I need 2 points. In this case, it's a little bit easier to do slope and a point. So, recall that one of the ways we're able to define slope is the rise over the run. And the reason I'm looking at that part of it, and I'll do this in red on the graph, is because if I go from the center to these two defining points, remember, this is the A distance, this is the B distance, right? And I know those, yeah? I know that the A distance is 2. I know that the B distance is 4. And we could calculate the C distance for the foci, but we don't necessarily need to this time, so I'm not going to go through it this time. We'll do that in a later problem. But, so what I can see here is that if I use this rise over run definition, the rise is 4, the run is 2, then 4 divided by 2 is 2. Now that's the slope for this one. Now, the only difference between that one and this one, they're of course going to have almost the same slope, but this one, as you move from left to right, moves down. It's on a downward slope as you move from left to right. In other words, if you were a guy walking, or a lady or a non-binary walking, when you got to this one, you would go down, right? So when that happens, you know that you have a negative slope. So let's label these as asymptote 1 and asymptote 2, let's say. I just need a way to distinguish them. Asymptote 1 is going to have well, let me do point slope first, and then I'll do slope intercept second. Is going to have a point slope equation of y minus some y1 equals the slope times, and the slope, which is positive 2 in this case, times x minus x1, some point. And my second asymptote is going to have the equation y minus some y1 equals negative 2, the slope of negative 2, and x minus some x1, right? So we have those options. We could also look at it as A1 has the equation y equals m, so 2 times x plus some b, and A2 would have the equation y equals negative 2x plus some b. All right, so good. So we have all that information. We could write it in 2 different ways. And the key is that the center is a common point for both of them, which makes the point slope forms really, really easy to write, right? Here's my x1, here's my y1. So one way of writing the A1 equation is y minus -2, which is the same as +2, equals slope of +2 times x minus 1. The other way of writing it requires calculation, right? This is why I'm doing the point slope form first. So let me do the point slope form for each. Let me get rid of that semicolon. So then the A2 looks almost exactly the same. It's y plus 2, that is minus -2, equals a slope of -2 times x minus 1. So there's one way to write the two equations. That is like the quickest way to write them. Then you could do them in slope-intercept form, also, of course. But to do them in slope-intercept form, you either have to simplify these two, which you could do, or you plug in an x and a y and solve for b, and that's how I'm going to do these ones, if I can make sure I have the room here. So we'll just plug in the center, right? -2, that's the y, equals 2 times x, which is 1, plus b, so that's -2 equals 2 plus b, subtract 2 on both sides, -2 and -2 is -4, equals b. So we get for A1, we get an equation of y equals 2x plus -4. You could write that as -4. And then for A2, let's see if I can sneak this in here. We'll use the same x and y, so y, which is -2, let me box that, equals the slope, which is -2, times x, which is 1, plus b. So that's -2 equals -2 plus b. Add 2 to both sides, and we get that 0 equals b. So we get an equation, I'll have to sneak it in over here, of y equals -2x plus 0, or just -2x. Okay? So there's all the ways that you could write the equations of those asymptotes. I hope that helps in finding the equations of the asymptotes. I'll let you look at that for a moment. And then we'll move on. All right, let's do something different here. Let's write the equation of the graph. And we need to note that the center of this one is here. How do I know that? Because here's a vertex, and I need to go directly to the center, right? So that's how I know that. So let's write down what the center is. We're still on a x value of 0. You should be able to see that. That is to say, so let me be a little more careful. There's a vertex at 9, 1. There's another vertex at -9, 1. So the center of these two, if you calculate the center between 9 and -9, that center is 0, and then the y value never changes, so the y value stays at 1. So that's how you can figure out the center, or you can calculate the midpoint by taking the average of these two, which you would find to be 0. So now I know the center, I know the vertices, and, those aren't really the vertices, are they? Those are the B distance ones. The vertices are at 0, 8, and 0, -7. Those are the vertices because those are where the curves actually touch the rectangle. Okay, sorry for that confusion. So there is some information. We know our A distance, that's the distance from the center to each vertex. And we need that. We can count that. But I believe I must have drawn this incorrectly. That must have been a 6, right? That's the only way that can work. I apologize again. Because from 1 to 8 is a distance of 7, and so that has to be a distance of 7 also, and that can only be a distance of 7 if I'm going from 1 to -6. So that's how I knew to make that correction. The distance B is much easier to calculate. It's 9, because from here to here and here is both a distance of 9. Okay? So I have A, I have B, I have the center, and I know which direction it opens up in. It opens in the y direction, so it's going to be of the form y minus k squared over a squared minus x minus h all squared over b squared equals 1. And then there's h, there's k, and I have my a and my b, so I should be able to put in everything that I need. So y minus k, k is 1 here, so remember you have to be careful that the y is first, so you have to look at the k first. So y minus 1 squared over a squared. A is 7, so 7 squared is 49. Minus x minus h is x minus 0, so I can just do x and then squared. Over b squared, b is 9, so 9 squared is 81, and the whole thing always equals 1 for most of these conic sections. So there is writing the equation from a graph. I'll let you look at that for a moment. And I think we're ready to move on. So now let's talk about for hyperbola. Here's some information. One focus point is at -7, 1. One vertex is at -6, 1. The center is at -2, 1. Write the equation. Okay. So let's draw this out. I always feel that drawing these out is extremely helpful because you get to look and see how everything looks, and then you can connect that with your own knowledge, which tends to make a huge difference, right? So negative 7, 1 is one of the focus points. So let's say that's like there. And then negative 6, 1 is a vertex. So there's a focus point, there's a vertex. Oh no, not on the axis though, up here. So that means that roughly it's going to look like that. And then over on the other side, we're going to get the same thing, but let's mark our center. Negative 2, 1. So then, what is this A distance? That's the A distance right there. And what is that A distance? Well, if this is negative 2, and that is negative 6, to travel from negative 2 to negative 6 is a distance of 4. Okay, so now we know A. We know A equals 4. How do we get B? Well, remember that, so from the center, there's going to be some mark for B, and then we're going to create some rectangle, and we have the other end of the parabola there, and another focus point there, and stuff like that. With that B point like up here and down here and stuff like that. So I don't know this B distance right there, but what I do know is that the hypotenuse distance is the C distance. And I do know the C distance because it tells me one of the foci. So from the center right here to this focus point right there is from negative 2 to negative 7. So that's a distance of 5, right? So again, what that right triangle tells me is that a squared plus b squared equals c squared in this case, and that a is 4, I don't know b, but c is 5, and so that gives me 16 plus b squared equals 25. I subtract 16, and b squared equals 9. And I'm looking for the equation, so what I really need to know is what a squared is, which is 16, and what b squared is, which is 9. So I just figured that out. I also, it opens in the x direction, so our equation is going to start with the x, so it's going to be x minus h all squared over a squared minus y minus k all squared over b squared equals 1. So that's the equation that I need to use. And now I have all the information. I have my center right there telling me h and k. So my center is negative 2, 1. And so there's all my relevant information. H and K are right there. So let's put this down. X minus h, that's minus -2, so that's the same thing as plus 2, and all that squared, over a squared is 16, minus y minus k is 1, all squared, over b squared, which is 9, equals 1. And there we have the equation of this hyperbola. I'll give you a chance to look at that. All right, and let's move on. So now, this is our last question for this section. If I tell you that you have foci at 1, 7 and 1, -13, and a directrix equation of y equals 64 over 10, and I ask you to write the equation. So remember, the directrix distance is calculated by a squared over c, and so we know that directrix distance, and again, I think it's going to be very helpful to write things out, to sketch things out, that is. That was an awful line, wasn't it? I'm just trying to extend those a little bit. So foci at 1, 7 and 1, -13. So there's a focus point there, and there's a focus point there, which means they have to open with those inside of them. All right. So how do I figure out? Now remember, this, the distance from wherever the center is to that is the distance c, right? So I kind of already know the distance c. I just be nice to know what this center is. Well, I know the x value of that center already, right? Because we're only traveling up and down to get that c value. So I'm not traveling in the x direction at all, so that x coordinate is going to stay 1, as you can see there. And then I have to figure out the y value. And the y value is the midpoint of these two y values. And to get that, I just take the average of the two. So I do 7 plus -13 divided by 2, which is -6, divided by 2, which is -3. So the other value for the center is -3. So now I have that piece of information. So then the directrix distance is something that I still have to figure out, right? Because, so why do I still have to figure it out? Well, I guess I don't really. Let me draw the directrix lines. 64 over 10 is, let's see, what would that be? That'd be like 64 divided by 10 is 6.4, right? So somewhere at 6.4, which means I drew that wrong. But anyways, it's always inside of there, so they're going to be pretty close. They're going to look something like that. Excuse me. And the distance is that distance d from the center to it. So how do I get that distance? Well, it's just a matter of subtracting, right? This distance is we're moving in the y direction, so we want to say the equation of the line, 64 over 10, minus where my center is in the y direction, so -3. So that'd be, let me reduce this 64 over 10 by at least 2. That's ridiculous that it's sitting there at 64 over 10. So it's going to be, what, 64 divided by 2 is 32, so it's 32 over 5. Minus negative is like plus. That is, negative times negative is positive. You can think of it that way too. And then 3 over 1, if I multiply that by 5 over 5, gives me 15 over 5. Giving me a distance, 15 over 5. Giving me a distance of 32 plus 15 is, sounds like 47 to me. Of 47 over 5. Right? So that's my d distance. So then what I know is that 47 over 5 has to equal a squared over c, and I already calculated my c distance, or I guess I didn't calculate my c distance yet, but I can sort of count it. It's 10, right? From -3 up to 0 is 3, and then up to 7 is another 7, so that's 10. Excuse me. Then if I multiply both sides by 10, I'll get, let's see, 10 divided by 5 is 2. 2 times 47 is 94, I believe. So we get 94 equals a squared. And remember, we don't need a, we need a squared, so it's perfectly fine to leave it that way, right? So I have a squared. Remember that a squared plus b squared equals c squared. I've gone over that enough times. So we got 94 plus b squared equals 10 squared, which is 100. Subtract 94 from both sides, and I'll get that then b squared equals 100 minus 94, which is 6. So now I have a squared, and I have b squared, and I have the center. It opens in the y direction, so it's y minus k. So let me put it, kind of running out of room here, but put it over here. Y minus k, k is -3, so minus -3 is like +3 squared over a squared is 94 minus x minus h, which is 1, all squared, over b squared, which is 6, equals 1. And so there we have the equation of that hyperbola. All right, that is the end of this section. Thank you so much for listening.